Hello friends, today's question. A container of width 2a is filled with a liquid, a thin wire of weight per unit length, and this is given as lambda, not L. Lambda is gently placed over the liquid surface in the middle of the surface as shown in the figure. As a result, the liquid surface is depressed by a distance y. Y is less than a. Determine the surface tension of the liquid. So this is the, you can say, front view, and this is the needle placed in the middle of the surface, and the surface is depressed by a distance y. So we can just draw the required portion of the. So this is the needle from the front side, and the surface tension will be applying the force in this direction, and we can divide it into two components. So this will be T and this will be also T. Let us suppose this angle is theta, so this angle will be also theta. So therefore we can say that we get this as 2T cos of theta, and in the downward direction we are going to have a weight W, and this is our y depression, and it is exact at the center, so therefore we are going to have this as A. Okay. So in this case we assume that let the length of the wire is given as L. Thin wire, let the length of the wire is L. So we assume that the wire length is L, and mass per unit length is given as lambda. It is given in the question. So you can say mass per unit length is given as lambda. Therefore weight of the wire that will be acting in downward direction weight of wire, that is W, will be equal to mass per unit length, that is lambda, total length is L, and multiplied by G. So this will be total weight acting in the downward direction. Okay, so weight of the wire in downward direction. And we have a vertical force due to surface tension, which will be acting in the vertical upward direction. So vertical force due to surface tension in upward direction let us call that as Ft. So this will be equal to our 2T cos of theta multiplied by L. So at equilibrium, the downward force W will be equal to force due to surface tension in vertical direction, upward. You can say at equilibrium, under equilibrium, we have WA is equal to Ft. We substitute the value. W is our lambda L G, and we have 2T cos of theta multiplied by L. Here L cancel with L, and let us find out rather cos of theta. So we have this angle as theta, this is our y, and this is our a. So this will be our a square plus y square ka square root. So therefore cos of theta will be equal to y upon square root of a square plus y square. But in the question it is given that y is very much less than a. So therefore we can approximate that our cos of theta will be approximate equal to y upon a. We substitute here in this equation. We can write that lambda g will be equal to 2t y upon a, and we are supposed to find out the surface tension, that is value of t. So we can get that t will be equal to lambda g divided by 2 multiplied by ya, or we can rewrite it, t will be equal to lambda ga divided by 2y. This is the surface tension of the liquid. This is the surface tension of the liquid. So yeah, this completes the question. Thank you.